Hello, this is our last video for this module 3.4, 3.5, and it's kind of a reversal of roles. So in the past, we were given a rational function, and it was our job to graph it. Now remember what graphing really illustrates. Graphing means finding the solution. So when you graph something, you want to find the solution to that given function. So in the previous videos, we were given the function, and we were actually finding the solution by doing this graph. Well, in this one, we're given the solution. We're given the graph, and it's going to be our job to find the function. So everything is in reverse. So, but if you look at the graph, now remember it's a rational function. So the first thing is you notice that it's a rational function, so you're going to have a polynomial on top and a polynomial on the bottom. So it's going to be our job to find out what p of x is and what q of x is. So I want you to notice a few things. The p of x, what are the x-intercepts? And what are they? Well, that's the way you find your x-intercepts. So if you look at that, the x-intercepts are -2 with an even multiplicity. What that basically means is that the graph bounced. Remember the polynomial aspect. So it bounces off of -2. So it's going to be x plus 2 squared. That's one of the factors. And another factor is at x equals 5, it has an odd multiplicity. So it's going to be x minus 5. So p of x will be that. P of x is x plus 2. Notice that it's squared because it bounced off at -2 and times x minus 5. So that's your p of x. Okay? Now, so the vertical asymptotes at x equals -5 and x equals 2. Now, vertical asymptotes helps us find the q of x. So since r of x approaches for the left of -5, okay, so and on both sides of that one, it's going to basically, what the last verbiage is basically saying is on the at 2, it's going in the same direction. So it's going to have an even multiplicity at x equals 2 for that one. And since it went from one side to the other side at -5, it will have an odd multiplicity. So it's got a lot of verbiage there, but basically that's what it's saying. At -5, it will have an odd multiplicity because it ended positive on one side of -5, and the graph goes negative on the other side. But at 2, it's going in the same direction. And they illustrate that there. So right, it says, so far we have x plus 5 times x minus 2 squared. Now, the reason it's x minus 2 squared instead of just x minus 2 is because it's going in the same direction on both sides of the asymptote. But at x plus 5, which gave me the -5 asymptote, it's got an odd multiplicity. So if you want to know why one of them is squared and the other one is not, the one that's squared is where it went to the same direction. It's kind of like bouncing on the x-intercepts. So if the x-intercept bounces, they have an even multiplicity. When the vertical asymptotes, when the graph goes the same direction on a vertical asymptote, it's got the same even multiplicity. Now I want you to notice what we have so far. R of x equals that. Now there's a couple of things I want you to notice is that the degrees are the same. It's a degree 3 on top and degree 3 on the bottom. So with what I've got so far, everything is good except the horizontal asymptote. Because the horizontal asymptote here is y equals 2. With what I have so far, the horizontal asymptote would be y equals 1. So what do you think I could do in order for that to have a horizontal asymptote of y equals 2? We put a 2 in there. Because remember, the leading coefficients have to have a 2 over 1, and the degrees are the same. So it's just a matter of putting a 2 on top with the p of x. Okay? And so that gives us you're not going, wait a minute, doesn't that give you another x-intercept? No. Look at the numerator on top. The x-intercepts are still -2 and 5. 2 is never 0 anyway. So the only reason that 2 is up there is to provide the horizontal asymptote to be y equals 2. So that was necessary in order for that to happen. Now you're like, well, what if you bring that horizontal dotted line down to 1? Then you wouldn't need to add any number because it would be 1's the horizontal asymptote. So all things being equal, if you move the horizontal asymptote up to, say, y equals 5, then you'll need to put a 5 there at that leading coefficient instead of a 2. So that's kind of how it works. So this is the function that would give you that graph that was given to you. So do you see how things work backwards? I had to find aspects of the graph I have a code. I had to find those aspects. And remember and remind myself, how did I find those on the graph in the first place? I mean, when I saw those vertical asymptotes, well, how do I find the vertical asymptotes? Oh, we have something that makes the denominator 0. That's what makes the denominator 0. So when I saw the vertical asymptote x equals 2, then I knew there was going to be a denominator factor that has x minus 2. And when I saw the vertical asymptote at negative 5, then I know I was going to have an x plus 5. And then sometimes vertical asymptotes are squared and sometimes they are not. And so if they go the same direction, like at x equals 2, that's when you got to tack on the square. And the polynomial on top, the Kobe rule still applies, like we learned in polynomials. The degree at negative 2 is even because it bounced, and through 5 it crossed. So those same things apply. So in essence, what you got to do is you have to work backwards. You gave me this. How was I supposed to find that in the first place? Use your rules to find them, and then just work backwards, finding the function itself. So if you have any questions on this video or anything else, feel free to contact me, and you have a good day.